are those
Oh, yeah. We'll get some of those sweet Python details.
We had some.
Go to Sci-Fi?
Yeah, well, that's where a lot of these came from, was going to the Sci-Fi conference.
Oh, yeah. That's why.
There
There are some in there. And we have MetPy stickers. Not in there, but.
The reverse alien model.
Yeah.
That's the login for our Linux.
Back in 10 years, we were all wrong. Attacked my belly publicly.
There we go. That's the goal. Did we ever give out new stickies? Let's see if we can get Roman cap those off. All right. Well, it looks like we got just about everyone here, so I guess it's time to go ahead and get started. Good morning. I hope everyone is more rested than I am right now. We're going to start this morning. I don't know, does everyone have the Jupyter Notebook up and running again? Do we need to cover some of those steps?
Still running.
Still running. That's one time I shut mine down is when I'm upgrading. Otherwise, it just sits there running all the time, just because I always want to drop in and do something. So what we're going to start with here is going to the Surface Data directory. And we're going to open a notebook called Surface Data with Siphon and MetPy. All right. Anybody not get this notebook up? All right. So, how many of you have ever had the pleasure of trying to hand decode a METAR? Actually, fewer than I would expect. What's that?
And decode.
Yeah. So we're going to work with Surface Data, and normally they come in this wonderful text format, hand-coded by humans. We are going to make use of a server that Unidata runs a package called Threads that provides access to a variety of data sets and puts a bunch of services on top of those data sets. It allows us to access that data without having to go through some of the challenges of working with data. Instead, we can just get it just like a NetCDF file, or in some cases, as literally a NetCDF file. So the first thing I want to talk about is threads. So I'm going to open up a new tab here just to show you guys. I'm going to go to website threads.ucar.edu. If you're trying to follow along, that was threads spelled like threads spelled like that, THREDDS, not threads as in string. What threads gives us is it's based around the NetCDF Java package, and you have collections of data on disk, and you configure threads to look at those directories, files, whatever. And that allows us to get remote access to the data. That can be anywhere from just downloading the data, the raw data files as there are on disk using HTTP, just like you would any other file off the web. But there are also more sophisticated access methods like OpenDAP, which allows you to access the data, only parts of the data. So you can ask for a certain index range of the data, like we were slicing with NumPy arrays yesterday. That same kind of thing, except for remote data. It also allows you to only request certain variables you need. So if you have a really big set of, say, model output, or an NetCDF file with a bunch of different channels from satellite, you could actually just download whatever particular data you want using this index range and for particular variables. So it's a really nice protocol to be able to save yourself a lot of work from downloading data you don't need. Threads also provides things like with a web mapping service support, which is another OGC standard for doing web mapping. And then there's a few metadata services. And then the last one, which we'll make use of here, is called the NetCDF subset service. What that allows you to do is for a variety of data sets, whether or not they're in NetCDF format originally, you can make a request, whereas OpenDAP, you're requesting indexes. With NetCDF, you can actually just request a latitude, longitude box or a particular point, as well as a time range. And then CSS is smart enough to be able to turn that into, figure out where in the data it needs to pull out, and then, as its name alludes to, the NetCDF subset service, it returns those data nominally in a NetCDF format. And some data you can get it as CSV as well, but one of the things is that you can just download a NetCDF file. So for things like grid output, you can have a huge collection of global grids in grid format and get back a small chunk for a particular lat long area of interest in NetCDF format and have a much smaller and easier to work with data set. So that's kind of what we're using Threads for. So if I go to this website, threads.ucar.edu, we see a listing, kind of just looks like a tree of files here. We have directory forecast model data that go in there. I see a whole big list of different models that are coming over the weather services NOAA port data feed, as well as a few other sources. I'm going to go back. So we have forecast products and analysis, observation data, radar data, satellite data. So the variety of data sets available on the server. What we're going to look at is observation data. We see we've got surface observations, METAR station data, surface buoy point data, a few other data sets. And under METAR station data, we have this files directory, which has all these NetCDF files containing surface observations. And we also have this link here that says feature collection. So as opposed to having to just access each individual file and do some munging of paths to try and say, okay, I need the file for 0Z because that's the most recent hour. Instead, we can just use this feature collection, let Threads do the wrangling of figuring out what file has the right data, and we can just access this feature collection and get a particular time and area of interest and let Threads do all the management of this. So going back to the notebook. Where are you? Okay. So we saw that web view, we had the file, the listing and whatnot. That's what we call the Threads catalog. And it's not only an XML file at its core. We don't want to work with XML by hand. That's terrible. That's ugly. Instead, we'll let the computer handle that for us, and we'll make use of a library that we work on at Unidata called Siphon. It's a library for remote data access. Focuses heavily on accessing data from Surprise and Thread server. And so that's where we're going to start. So that's what we're doing. This first import here is we're importing Siphon. And actually, we're specifically importing this catalog module part of Siphon. So that gives us access to, we're going to import this TDS catalog class here. And that class is able to parse the Threads catalog and do what it needs to and access the server remotely to make sense of what's up there. So I'm going to first import that catalog class. This is the URL to the feature collection right here, this metar-cat URL. That was just what I saw when I went to the feature collection over here on the server. This URL right here, or rather this page I'm on right now, is the URL I gave it. So I just copied that in my notebook. Come on. There we go. So I copied that here. I just have the URL, and then what I say is TDS catalog, go parse that URL for me. So download the information, the XML, parse it out, and give me something I can use. And I can say, what data sets are in that catalog I just had you download? And so that's what I'm printing out here. I have this catalog data sets, which is a dictionary that says, here's the name of a data set, and it gives back some representation of it. And so I'm just printing out a list of those data sets to see what's in there. So we see there's one data set in that catalog I just downloaded called the feature collection. And so I'm going to pull that out, just using the same dictionary thing like we were doing yesterday with NetCDF variables. In this case, it's a different kind of dictionary, or different dictionary, different things. But we can still just do the feed of the string and get back out what we're looking for. So I pulled out this metar data set. Now, what good does that do us? One of the things that provides us is a listing of all the different access methods that are available on that data set. So be that the WMS access method I mentioned, or OpenDAP, or just HTTP download, all those are encapsulated here. So if I want to see what access methods are available, there's another, on this data set object, there's another dictionary called access URLs. And we can print out a list of it and see, okay, the one access method this particular data set has is NetCDF subset. And so, again, I'll pull that out of the dictionary and we'll just print it. It gives a URL, so it maps the name of the service to the web URL you use to access it. We'll just pull that out and print it out just to see what it looks like. And so now we have this URL pointing to it's a web URL on the thread server that we can hit and get things back. I could click this right now, and what that's going to do is give me an error because I haven't provided enough information. So far we've just done catalog parsing, and it's a few steps to go from point it somewhere on a thread server, let it parse the XML and pull out the relevant metadata, and set up simplified access to the URLs that are hidden in that server. So if I went back to that web page, I can click on this here. That's that same URL, slightly different URL, but it's the same service, and it brings up this big HTML web form. It has these check boxes where you can select different variables, select a latitude, longitude range, maybe a time range. And you can do all that by hand through an HTML form. As a programmer, I don't want to do this manually. I certainly don't want to do this on a repeated basis and have to, if I want to download data, come in every day and do this by hand, click these boxes, and manually download data. So we're going to take advantage of something else within Siphon, a client for this particular service that will allow us to programmatically do this process of clicking on, selecting variables and selecting a time range. So that's the next portion here. We'll import the NCSS client, the NetCDF subset service client. So from siphon.ncss, import NCSS. So that gives us this class name available. And then we'll just hand it the URL we just got out of the catalog. And so that's gone. It's hit that server, downloaded some more metadata about the collection. And so we can do things and say, what variables do we have available that we can select from? So we created this NCSS, this lowercase NCSS instance that's pointing to the METAR collection on the server. I look at the variables and see here's air pressure at sea level, cloud area fraction, dew point temperature, all of these various surface parameters.
Do we know the units associated with those?
When you get it back, they should have the units in the NetCDF file. But we don't know the units as far as I'm aware right now. So we've got enough information to at least say what variables are available. We have enough information to ask for things we might want. So let's go ahead and talk to the server and say, this is the data I would like you to return to me. And so at the start, we'll get the current date and time. So here, I'm going to go back to the datetime module and import datetime and an additional class called time delta. So that's another Python standard library utility that works well with datetime to provide ways to do math with datetimes. So if you have a time, you can use a time delta to add and subtract an arbitrary amount of time from that. So the next line, we'll get the current time in UTC. And then I'm actually going to tweak it to strip out the minutes and seconds and just give me the most recent hour. So that's what the second line is doing, saying, okay, really make a new date time with just the year, month, day, and hour, and throw away the minutes, just to try and go back to the most recent observation time. So that's all the time, just manipulation to get the current time without the minutes. Next up, we're going to start setting up variables to define the time range we want. Let's say here's the start time. That's this now time I set above. And I'm going to subtract off a time delta of 1 day. So take the current time, or current most recent hour, and then go back 24 hours. And then the end time of our range that we want is now. So we're trying to go 24 hours in the past. So now we're on to trying to assemble what we call a query for NCSS. We're just trying to assemble the different parameters we're going to send to the server to say, this defines the range of data I want you to give me back. These are the variables I want. This is the area of the globe I want. This is the time I want. And then there are a few other parameters in terms of slightly changing the format of what's returned. And we're going to see this pattern a lot today. So first we make a query, just an empty query. We take that NCSS instance we created above. We call query on it, and that returns us an empty query object that we can start building. And so for instance, the first thing I'm going to do here is I'm going to request a particular lat long point.
Could you do a range, or is this more something you'd like to put in a loop with?
Sometimes it depends on the exact nature of the data you have. In this case, on the point data, you can do a box. For things like we have model grids, and we'll do that this afternoon. I can't remember if I showed both ways, but you can do a point request to the model grid, and it'll find the closest grid point and give you a time series back, or you can do a box request and get back that area over it. So it can vary a little bit. So what I'm trying to do here, the end goal is to try and get a time series of actual surface observations. We were opening local NetCDF files before. Now this is building on that. Instead of doing a local data file you have, go hit a remote server, download only the portion of the data you're actually interested in, and make a plot. something you could script up and use to power your own weather site, as opposed to, needing to have all the data locally or needing to manually go down all the files. You can script up this analysis and make things more repeatable. Be a lazier programmer, because that's certainly what powers a lot of what I do, is saving myself effort, and try and make things more flexible. So that's our goal here.
Question.
Yeah.
Sorry, you may have said this already. I missed it earlier.
No worries.
This is, what data is, it's global coverage?
It's U.S. surface station observations. I think it's. I'm not positive if these surface stations are global or not.
The synaptic ones probably are. The
But,
guitars probably are.
That's
They might be. You would try it. Better pull up something.
not sure.
And then temporal coverage is how?
On our server, we probably actually looked like we had about a month and a half of it, but we don't have a long-term archive here.
But it's typically once an hour.
Yeah, they come out once an hour. The time interval is about once an hour, but I think we have data on the thread server going back to about April.
And is it are they interpolated values or?
No, these are the actual observations.
But you gave a specific level.
Right. So what the thread server will do in this query is find me the station closest to this point.
Okay.
So another question about that. BTAR has two different formats. In the US, we have one that gives us to the nearest degree Celsius, and so we can convert to Fahrenheit.
Mhm.
Whereas the rest of the world just gives us gives us the integer value of the temperature. What are we going to get out of this? We get when it decodes it, does it include that extra data that the US provides?
Currently, I'm not positive. The software that's powering that data feed right now is based on NetCDF Perl. So it's a little dated, and it's on my list of things I'd like to update and clean up what it's doing. And then in that case, when I get around to that, it will absolutely be using the best temperature values that are available, whether it's out to the 10th or whether it's the.
You can take a look when we do exercise.
I want to say this data looks pretty quantized, so I think it's the nearest degree data only.
Okay.
All right. So we're going to ask for a particular long lat point. So longitude minus 104.66, 39.85 north, negative 104.66 longitude, 39.85 north latitude. So that's in the ballpark of Boulder. We're going to ask for a particular time range here. So this is we'll give it the start time we put together and the end time. Well, so here are the variables we want. We want the inches altimeter, the altimeter setting in inches, air temperature, dew point temperature, wind direction, wind speed. And then the last thing I'm going to do here is I want to say add this accept parameter, which is how we tell the server, I want NetCDF back. So we can see what this query object's really doing. If we first print it out, it gives us a string, which if you've ever looked at your address bar in your web browser when you go into some of these web services, you see strings like this attached to the end of the URLs. So this is a thin wraparound building up the web request to the server. But this few lines of code reads a lot better than trying to generate this manually. So from there, let's go download the data. So we can say data equals NCSS.get data and pass it to query. So we have this NCSS object that's pointing to the server. We built up this query. We hand it the query, and it goes out, fetches the data, downloads it, opens it up for us. So we get this data object back. What does that look like? Well, it's just an NetCDF object, just like we worked with yesterday afternoon. So it has all the, has this data.variables method, or has this data object that has a variables attribute that allows us to pull apart our data set. So we've got latitude, longitude, station altitude, station ID, as well as there's our wind direction, wind speed, air temperature, dew point temperature. So we're curious to see, I give it the line point, what station did it actually pull out? So let's pull out the station ID variable and look at what we got. Well, when we do that, we get this awful looking B, D, B outside quote E, B outside quote N. What that amounts to is it broke up our string identifier into separate elements, and then they're actually considered binary data right now in Python. They're not being considered characters. That's what that little B denotes, is that Python's treating it as binary, just bytes, some value in the range from 0 to 255. So we can start pulling this apart, and I could start by saying, okay, if I use the array method to bytes for the NumPy array, then I get things at least slapped together. That's a start. It doesn't look so bad. I can at least read it. If you're working with binary data and you want to try and solve this and say, you can just tell Python, this binary set of bytes, you need to interpret this as ASCII characters. Make a string out of it. If you know it's not ASCII, but say some, you have some international characters or some other complex things, you might need to use a different encoding like UTF-8 or something. Luckily, this is straightforward VTARs, so we can just assume ASCII. So what I do on the next line here, so I pulled it out, I saved it as variable station ID. I say station ID decode ASCII. And now I've turned it into something, an actual string.
This is a silly question. Is there an advantage of using ASCII over UTF-8?
It's a really good question.
Normally, I'm covered with UTF-8.
I can't actually, no. So yeah, UTF-8 works just as well. So pulled apart the station ID. Oh.
But I'm a little confused on line 9. How your print list data variables was able to pull that long station altitude without the query defining those to grab the bit file.
Say that one more time.
Line 9, you have a print list data variables.
Yep.
So latitude, longitude,
Mm-hmm.
all that info. How do you access that or retrieve that without the query defining those fields to grab?
Oh, because the query didn't say anything about latitude and longitude?
Right.
Correct. So some fields, as far as the metadata information, will always be returned by the thread server. So in this case, we couldn't make sense of where the data are without that information. So threads, in addition to what we ask for, automatically adds the latitude and longitude from the data set to what it returns to us. So that's kind of the server being smart enough to give us that information.
Are there specific things that show those besides that one?
Well, the only things we requested are these last 5.
Okay.
So everything up to this point is what the thread server added to our request. So latitude, longitude, altitude, station ID, station description, the WMO station ID, as well as the time, and for some reason the station index. And that one, I'm not sure why it added that.
How do you know to do query the black line point, query the time range? How do you wait to get a list of query to get that? How do you know query the variables?
Okay, so to know what variables we have available, that was up here, where we had this NCSS.variables after we initially talked to the server.
So we did the query attributes like query the black line.
Sure, comes from it's not specific to the server, it's more of the feature of Siphon, so that just comes from reading the documentation or looking at the examples or coming to this workshop. What was that? Yeah.
We can do like.
Oh.
Get out of list of query to get.
Well, let's see what happens if we do a dir query. They're there if you're willing to scan past those.
Okay.
Not all of these are actually functions, though. Like var isn't something you could call, but variables, vertical level, strides, or yeah, strides, all times. So there are, you can see them there, but it might be a bit of trial and error.
Why is there no leading K for DEM?
Because that was a decision made by whoever made that parser on thread server.
So if we do go to, say, Europe, we'll get back a 4 character.
Oh, I'm not willing to say yes to that statement.
Well,
Should you? Yes. Will you?
I tried, just change lat long to positive 104, and I got back a station in China, I think, with a 4 character.
You did get
Yeah?
a 4 character.
Okay. All right. So back down here, after we've finally did some Python massaging to turn our station ID into something more useful. So we got this data from Den, so the Denver Airport Station. Now we're back to, we got times back from the server, so let's use NetCDF's num2date function again and turn those times back into an array of date times. So do the import, grab the time var, time equals num2date, the values in the units. That should look familiar from yesterday. So we're working our way towards getting a time series plot here. But one thing I want to point out here is if we look at that array of times that we got back, we see we got June 5th, 21/4, 2035, 1953. So they're not in sorted order that we really want right now. In fact, they're reversed, but the server will return them in kind of an arbitrary ordering, which is not particularly helpful. So remember when we talked about Arcsort yesterday in NumPy? That's why. So we can go back to that. We can import NumPy. We can use Arcsort on time to get an array of indices to sort our data. So this one's short enough we actually look at this and make sense of it. So sort ins is 210. So if we we can index into time using 210 and get things back now in properly sorted order with increasing time.
Was there hours and minutes? Is that what that's-
Yeah, so year, month, day, hour, minute.
Why not a full 24 observations?
That's a good question. I think I need to go, when I fling you guys off to go do an exercise, I need to go log into the server real quick and hit it because it looks like it got stuck. So I was just glancing at that saying that's yesterday's data. There should be a lot more points there. So yeah, we need to go kick it. Okay, so now we can get the temperature data corresponding to those times in the proper order. We say data.variables air temperature, and then pass it our sorting indices to get those in the proper order to go with the times. I'm also going to go ahead and pull out the temperature units here for plotting. So I say temp units equals data.variables air temperature units. So if I print that out, we can see, okay, they're in Celsius. And then just like yesterday, we'll make ourselves a little time series plot here. So percent matplotlib inline to tell the notebook to set things up with matplotlib plots embedded in the notebook. We'll import matplotlib as PLT again. And we'll also go ahead and use the fancy date formatting. Create a figure and axis and plot the data. And then set up a title, an X label, and Y label using the temperature units here for the Y label. I guess I should also mention here when we're doing the title of the plot, I'll throw in the station ID that I got back, as well as at least format the date from the first time I got. And then here's a few lines doing some more of the advanced ticking with the dates. So in this case, I'm going to use the auto date locator, which just kind of tries to figure out nice, even ticks to do depending on how big a date range you do. And then I'm just going to say format the ticks with just the hour. It's a little less interesting since I only have 3 data points, but I'll fix that in a second. So, any questions on all that? I know it's a lot to go through, but we'll get you some hands-on here. But any questions before I turn you loose to go through doing this on your own? Yes?
Why does it spread out, excuse me, the hour 20 all across there?
Probably because I only have a 3-hour span.
Why would it just be like between 3 points then instead of?
Well, so here's the,
They're all around.
this will clear it up, I think. So there. So we have a 3-hour range, so it's ticking something's finer grained than the hours. And I only said format it with the hours, so it did what I asked. It just makes a confusing plot.
Thank you.
Mm-hmm.
And this is more of a programming style
Sure.
question, but I noticed that you bring in your imports kind of when you start using them.
Mhm.
And when I started coding, I would just put all my imports at the very top. And I mean, is there a preferred style?
If we're doing a script, absolutely imports at the top. For a notebook where I'm doing sequential teaching of stuff, I like to delay the imports until we bring in a concept. But if I'm writing this, if this was a standalone program I was doing, absolutely imports at the top.
Sorry, this is going back to something
Nope.
yesterday, but can you go back to the sorting again and just
Sure.
explain the
Odds are, if you have this question, at least half the room has this question. Right there.
just
Mhm.
explain the steps of what
Sure.
the
Okay, so we'll walk through this. So Arcsort gives me the indices that would sort the array. So if we look here, if I'm going through this array and I wanted to sort it, the first value I want is this one right here, right, 19Z.
Right.
Well, that's 0, 1, 2. Okay, that's the index to that item.
Right.
So we get back 2 is the first thing. Then the next value, if I'm sorting this array, I'm going to pick out 20Z here.
So how does it know, I mean, since the only indices that are different are the minutes and seconds, how is it?
It's able to compare the date time objects and say which one's greater than the other.
Okay,
So that's one of the things about the date times is you can do comparisons between them and say, is this time greater than this time? And so the sort operation and does a bunch of, is this value greater than this? Okay, I need to put it somewhere else.
okay. Got it, okay.
Could you do a reverse sort?
Yes, although I think,
Colon, colon.
honestly, the easiest way to do that is to slice the indices and just tell it to flip. So if we go back to our slicing yesterday, the colon means we're going to do a full slice of default arguments, and then the stride's -1. So I don't know if we actually showed negative strides, but strides don't have to be positive. You can use it to skip every other. If you use a negative stride, it starts at the end and goes backwards. So it's kind of a quick way to reverse an array or reverse a particular dimension. So in this case, we have the indices in one order, colon, colon, -1 will give us in the other order.
Okay, go back to the plane.
Yes.
Is there any minimum items we need to stay here in order to get around?
You said it again?
Is there any like minimum statement we need to stay here? If I eliminate like that long.
Gotcha.
Well,
Yeah, it doesn't like it. You have to give it some kind of spatial query, which, let's see. If I do this, I think I'll delete this or comment out this line. Don't delete it. And if I ask for the data, yeah, okay, we get an error back. That gave me a weird error. I think that is an unhappy server right now. I was hoping the error message would be better, but it's not at the moment. So you need some kind of spatial query. You've got to tell it what area you're interested in. You've got to give it some kind of time range or say all times. And you've got to give it at least one variable. Those are the three things you have to give it. Okay, if there's nothing else at the moment, if we go back to the surface data directory, and there's another exercises notebook. So open that up. I think I have my old stuff in here. I'm not sure. So you see if yours looks clean, or did I do something horrible? No, okay, this is just my old stuff. Okay, so just your turn to try and go through that same exercise. Go pick a point, a lat long point, and go make the query and download the data for time range, station of interest. Plot the values of the function of time, and play a little bit with the matplotlib formatting and just try and get comfortable with what's going on here with using Siphon and making the query. And then we'll be happy to ask questions when you have them. In the meantime, I'm going to fix the server.
Jen said she was going to have a lot of fun bouncing them until the end of the day.
Thank you, Jen. Okay. I'm not logging into the server on screen. Oh. Oh, come on.
so this is just one of the decoders that comes in with those LVMs.
How fast can I do it? Can I stay ahead of them?
Because I knew they had data on the thread server, where it was coming from, and poked around and eventually found it. So I can share what I have, and it was.
I might just ask Sean or
It depended on.
Yeah. I mean, theirs is coming in clear.
It depended on getting the job of missing a Perl one, which hasn't been supplied anymore. So that was the challenge.
Oh, crap. That's. Hmm. Denver's still giving me 3 points back, but if I go to a different station, I get a lot more data. So I don't know what's going on.
How do those .nc files get generated?
LDM decoder using NetCDF Perl.
Which I thought I was playing around with that, like, let's go right, I just found it again. And I think I may have kind of had it working. And then Sean said, yeah, it might look like it's working, but the data might not be there. Because there was some issue with NetCDF Pro not working with NetCDF.
I have a half-baked Python 1 that just needs some more love.
You have a what?
A half-baked Python-based one.
For source data.
I think I made a mistake of trying to use multiple threads in Python to talk to NetCDF, and that's a surefire way to get core dumps. I would stick with the metards. So if we go to observation, go to metar, and don't go to files. Go to the feature file.
Oh, that's why I go to the file. I don't find
The files, yeah, they're weird. They're a weird NetCDF. They're a weird encoding of NetCDF.
I mean, it wouldn't do real time, but if I use the NetCDF Java point data that takes like a JPEG file and converts it, theoretically it should work. It just wouldn't be kind of like a real time thing, but.
Theory that should work. The only question is, well, if NetCDF Java understands the data, then you can get the collection. I mean, that's the real nice part, is to get the collection of the files.
So it's like the Madison's the station, just one time shows up. Just.
I would try that or change your time range just to see. I wonder if that thing was having
One of
issues.
the decoders not getting long.
Could be.
Albany.
I did a station close to Norman, I think Shawnee, and I got a decent amount of data, so it's not completely borked, but obviously Madison should have more than 1 point, Denver should have more than 3.
Yeah, Albany's not getting anything good as well as they today.
And I don't have any surface data on my thread server.
That's all right. Well, I bounced the thread server. At this point, it's a data feed parser issue.
Yeah, I just ran this, and it's completely about not being able to open the NetCDF, which is weird because it shouldn't be there. I'm trying to run, I found the NetCDF Perl stuff, the retard decoder, and I was playing around with it at one point trying to get it to go. It actually compiles and does something, but it's not doing the right thing yet. I think at that point, Sean is like, yeah, probably a lost cause. I mean, obviously it's working out for you guys somehow.
Actually, this data doesn't even look right because it has the temperature in Albany like spiking up in the wee hours to like 26°C, which is definitely not perfect. So,
Time offset problem, or time versus local.
I mean, it definitely didn't get close to 24, 26 yesterday.
Yeah, there's some problems there. But I mean, that's the script we're running. That's vtar to nc .new.1.2.
That's exactly the one that I'm playing.
Okay.
Also, did you know you could make a linked list in NetCDF?
No.
The actual raw files for the NetCDF files from that script invented a linked list in NetCDF. Yeah.
Post on it in the developer's blog.
For NetCDF Perl.
Within the NetCDF file itself, they're encoding a linked list kind of structure.
So if I had just a local file, can Python or Siphon handle like a file URL?
Do the queries, you mean the subsetting type things? All that query, the subsetting is done on the server. So Siphon only has the smarts to talk to the thread server. Xarray, if there would be the right tool for that, I'm not sure how it does with NetCDF point data.
Yeah.
Or spin up local threads on your machine.
I wonder if I had the Gempack surface file on my thread server. I mean, it should auto convert to. I'll try that.
That's a good question. So a lot of the time I'm trying to pull data down locally so that I can do I can create more visualizations, right? I assume I can't use the thread server style thing in order to do that because I actually need the grids locally in order to say run on grid and start stacking up the files that are necessary for that initial.
So I don't think you can today. We have talked extensively about trying to make it possible to use that for WRF initialization, to make some kind of default configuration that'll get you all the variables you need to initialize WRF. The challenge is actually getting WRF initialization to read NetCDF, which it doesn't do.
So I run into a problem where if I want to do this regularly, I have to pull down the data regularly, and I typically use curl in order to do that. And curl just likes to wig out at random. And so if I'm pulling down data that's on some rotating archive somewhere and I don't notice that and I try to build in all these redundancies into it, and it just seems like it always finds some way eventually to slip through. So I was curious if there's a Python-based solution that would replace curl.
You could, well, I mean, you could. Python certainly has the tools available to make a replacement for curl.
There's also direct Python bindings to curl, but Python has URL lib in there that allows you to hand it a URL and just go request from there. Also, for a thread server, if you can get access to the raw grid files from a thread server, so you could use something like Siphon to scan through the catalog and get the most recent one, and there's usually an access method of HTTP.
Okay.
Allows you just, here's the URL you need to hit to just download the file as it exists on disk. I think we'll do that with the satellite data this afternoon.
Okay. So that's something something I can apply the same methodology to.
And then I think somewhere there's a thread server on Nomads.
Yeah.
But I'm not sure.
I know there is.
Threads or is it GDS? I mean, Nomad's end stuff is it GDS?
Well, they're somewhere they're running a thread server as well. But I don't know if it's
NCEI is. I don't know about end stuff though. At least for model data.
Yeah, I don't know if in the model. That's what I'm not clear on.
Yeah, it's just uncanny the way that things slip through on the call. Interesting.
There's always something.
Do you know what the catalog rubric is for point data? Do I just change this to grid to point?
Oh.
To harvesting.
I mean, I'll just still give you the individual files, but that's a start.
Yeah, so the meters, they're typically hourly. I guess they're reported hourly, but they're actually available every 15 minutes or so.
Yeah,
It's 20 from.
So there's speckies too.
Yeah, the spec, yeah, especially. Can I stick over SAOs? Way back when. Remember those?
I remember. I don't think so. There are still a few coming across the IDD though.
Yeah.
Seriously?
Yeah, I've run into a couple. That like,
Yeah, Canada. That was back in
Yeah.
the day. Canada still has SAO.
It would be one of the good days. Early code is not LSOs. Did you check to see if it does the full Fahrenheit or just
No, I haven't checked that yet. I'm just. So it's altimeter setting, but not.
Yeah.
Pressure.
Yep.
Why is that not in that?
I don't know if it's decoding that group or not. Honestly, I've looked for it. I'm like, why are you not there? Somewhere I think I fudged it and used still 10%. Just not like at sea level pressure.
So I should be able to convert that, right?
Theory.
Okay.
We have a standard atmosphere function.
There's in the log for the attempt at converting METAR to NetCDF that failed because it wouldn't open the NetCDF file. There is a reference to T_tense and TD_tense, so there might be tense degree in there.
All right.
It didn't actually work, but the log here was interesting.
Sure. All right. So are we looking at or are we looking at local samples?
Which would be right if I did it correctly.
So if we get something here that's 18Z and it's Denver.
18Z is
Midday.
It's
All right.
shared library.
So, okay,
That wasn't being built in NetCDF. It only writes NetCDF 4 and 3 files. But I had to build NetCDF 4 and NetCDF 3 support to get that shared out. And it took a while to figure out. So you have to go in
What I've gotten
NetCDF 3 to NetCDF 4 and run it, and then it failed because of some method. It wasn't pretty there. Yeah, now you're not getting NetCDF 3 method. Evaluating what's on there, so this will get 3 and then just run the file. Different deals in there.
Yeah.
Let me look back at it, but that's what they said, awesome, yes.
I did.
Technical needs, that's just like a technical detail.
So this is, so I just added the files to my
So it's just pulling it in on Windows.
Yeah.
So that works right. If we actually have data. That would be sweet.
This is kind of why I was
So.
asking, like, you know,
Sometimes I just don't see it.
Well,
An example
it's all
of
in
it.
NetCDF job.
either way, the station should be working the hour.
I kind of randomly.
And I did something different.
Here's the trick.
And I can try something
But
different.
that would make that huge.
It's like
Honestly, you might go back
dialing up at 0, 0.
Further into the times.
I don't quite understand. I thought this would be the
For the plug data.
I don't know what's going on, so you're just dragging it back.
Well,
Server-
there's just a ton of ways. So here's the 100 stride, if I just do it.
Impact service data pipe through threads is sending out data.
There you go, Kevin.
I don't know.
Threads.
I don't know if this is the
I mean,
wrong way.
the variable names can change because they're gonna look like
Did
Jetpack.
you get that from raw file?
You could, you know, do TNPC or something.
Base map before,
Honestly, what we did, we usually did.
Yeah, that one doesn't.
So I.
So don't pick a file, you wanna pick the feature collection. Because the files are.
So I need to go back.
Yes.
So, map projection problems.
Oh.
You might need to probably.
kind of
Go ahead.
so in this case, it's.
Put that in there.
Transform a little bit.
Which that's hidden, yep.
That's the data core, yeah, and that specifies the height. So if you change that projection, okay,
Actually, that one you see.
Kind of,
it is.
if these are just lat long points, then why did this thing go down?
Okay, so that long one. So you just give me
So this somehow is how I'm showing it.
Okay, so it doesn't like.
yeah.
Don't have.
Oh, you hope a cat.
It features overall.
That'll do it, so it's here.
Overall, my most of the paper is the one I have.
Yeah, and that's closer.
Well,
Well, I mean, now that you're access somewhere else.
Where I wasn't out there because I had like one line on it.
That's it, yeah.
Hey,
You're a programmer ever. Looks like my days.
At least I also confirm that you can pull up the.
Okay. This one's giving you good data?
Yeah.
You use research.
That's reasonable.
Yeah, I have them set up, but I don't really use it.
I don't know, some stations are not giving us a lot of data right now, I'm not sure why.
Yeah, I put in, I've done
And also
Reagan
reports
and
that
I've done Gauss, and
be out there.
this is what Gauss gives me.
This thing all the time.
I don't know.
I'm gonna guess it's a big coding problem, but I'm not positive about that. Either way, it's not exactly it.
I mean, at least this is right.
I rebooted the server, or I rebooted the threads software, it's not giving me errors.
You can send somebody with a C if there is. Are they universal code?
There you go.
Well, okay.
But if it's something that's on the. Excuse me.
Yes.
Trying to find from yesterday. For conversion, I'm trying to read this version from.
Okay. Sure.
Is it any empty?
Declaration? Well, you need to import, yeah, okay.
Okay, so I'm just looking back, that's the
Yeah.
thing, so what I did was I imported this, and I believe
But
that's the variable name, and then it's .2.
But you need to attach the insert.
I don't know. I don't know why they have a temperature going down to 5 centigrade and a dew point temperature going to 40
There you go.
at the same time. But the series of bad data points. But but we actually have other than that set of data, 2 or 3 data points for
All right.
something.
So I'm getting that.
And I'm wondering if it's has the kind of sensor they have here. Is it?
What I don't have,
Yeah.
I don't have the feature collection.
This is short mean.
Which, yeah, okay, it's not everyone, it's a one-liner, so I'm gonna try to see if I can back it up.
I know they record every 20 minutes or so.
Hey, Ryan.
So I call it, so the variable name is all ultimate data.
Sure.
Two, and then.
And one thing, we can go back to the other example. So. We can't just, so when we need to multiply by the units to tell what units it's in before you can do that too.
Doesn't it, no, it's like call the units thing on that, that's it, it's an inches.
Oh, well. It said it was inches too, didn't it?
Right.
Which is,
Oh, this only uses this side.
well, okay, so the NetCDF variable knew it had a unit, but, that's not telling Python anything, but just like it's sitting there as an attribute, just like saying the long name is altimeter setting.
Okay.
So you still need to pull it out. And actually, the string is literally inches. It didn't say inches of mercury, it just says inches, which you don't want to use that.
I'm just trying to figure out how to back it up. The feature collection. So it looks like I can back it up, but.
So if you go to the TDS config repository, some of those have it in there. I don't know if they can't
I
take
just
this
backed it out. Collections. This.
No, I don't know if if you hit the server, I don't know that, we call that the client catalog. I don't know if that has all the information you need. So if you go to the repo Unidata/TDS config, all of our catalogs are in there. Actual ones that are on the server, and that'll have a selection.
Let's say that goes down to the.
Okay. So I can. What I'm gonna do is. Convert it.
Oh, yeah, I know.
That's what we're saying. Units are inches, major. So we got the nice strip off.
Is there a way to get the raw meat chart from threads? Because you got a funky data point, so you want to get the raw meat chart.
I think the report's in one of those variables. You might need to go to the original pages. Actually, look at the variables thing on NCSS and see what it has.
Yeah, you could use the .2. Right.
I have to first make it inches of mercury.
Okay.
This is just easy.
And by the way, no rush here. I'm not trying to move anyone along, but just so I have an idea of where the room is. If you are ready to move on, so if you're still playing, let's, you know.
Unidata and see what it is. No, you can do a dot and do a units dot and then.
There's probably some benefit.
That was really cool.
Mantis has a lot of things we just haven't managed to bridge that gap yet. Schooling in place, too many obstacles.
Yeah.
Getting our data
Just
into
G,
our
okay, so-
parsing data
Oh,
now.
So
But I
then
think
you
in
could
another
do data dot.
year or two will probably be. Look, I haven't done enough of this really teaching it.
Well, it's like all, yeah.
It's probably not the best tool to look at.
Times units.
X-rays and more.
That's
And that's another one that's like probably a year. Tools, not enough.
Right.
Alright, so just to give you an idea of
Specifically references.
what the actual readings look like. They all, and
And that's
Yeah,
what
yeah.
the-
one or two,
Those are just work right now.
not a single one is,
And then you should be able to generate it to.
not a single one is
Oh,
formatted.
I see, I see. I should have.
But I'm
It's got a similar-
I'm showing you what the last 24 hours is.
Now the question is,
Why
the time
can't,
makes sense.
I don't know if I've seen.
We actually did it.
A model of this, that.
let's see what we get
So
for,
your
I
alt
think it really
units, you
formed
can
right in the
generate
Yeah.
units.
maybe,
You have alt units equals alt data.
I got this one at sci-fi.
Alt data dot twos.
I mean, I would go on that
alright, this is something I don't know. How would I be able to print the temp, like this, the air temperature, and then the dew point temperature, and then security as we go down. If I know, usually if I print one and then it's not the other one, I print all of one and then all of the other. Sure.
So you want to do,
That's okay.
you know about Python?
Are you plotting your alt data?
Alright. One of those things.
No, I'm plotting,
One
I'm
is
plotting all data.
a long time, so I'm sure it's gonna be easier to come up.
Because then you get alt units should be millibars.
Print all units. It's not print like that bar.
So if you think of temp data services lists, what Zip's gonna do is it's gonna
Those are, okay, so.
Walk through them
Personnel actives.
in lockstep, so like pull an item from temp, pull an item from dew point, and then
I don't want to call them that.
and then you can just iterate over that and keep giving you.
Okay. And then
So,
let's
what you
run this
did
and
was-
see. Well,
Like just do this,
Man's are
right?
okay,
Like
man's
just-
just missing that data,
First we do this.
or any of those correct.
alright, let's get a,
Well, that would be.
let's get these in Fahrenheit. No, we should be at 1:1. Okay. Alright.
First time is
18, that's not gonna work. Let's see if we can find 21.7, 20.
So not usually something to do with farming or this, but.
No.
I only keep saying I'm working on it. I haven't worked on it in 2 weeks, but that's coming back. It's gonna, I mean, I want it to go down.
Yeah, but it should be
It's just,
15.
That's why I'm saying.
Oh, I'm looking at the top. All right, 20,
Fair question. Yeah,
21.7, 20.6.
She asked for what.
So it looks like that.
You were saying
Yeah, but some of the other ones aren't. The time isn't
The
correct.
Gunnar one's like 75 pages, but so it's.
19.
It's WWRP report somewhere. This is what I pulled. This is the first thing that showed up on Google.
Yes.
Google Scholar.
News flash.
Yeah, this is WWRP.
Parsing stuff with parts.
Yep, okay.
TLDR.
I actually have left. Okay, CardPy and MetPy. Okay.
That'll take us to 11:30. And then I'll do half an hour of satellite.
We're solid with that.
And then I'll take half an hour after lunch.
Yeah. After we do this, models are easy compared to this. All right, anyone gonna be upset if we move on? Okay. I know that last one was kind of more just rehash of what we've gone through, but you want to see what I put together, if we put it all together in one cell here and walk through it again? Yeah. Yes, okay. All right, so here it all is the full end-to-end with one. I'm actually going to leave this as is because I at least have data here, and I'm not sure if my server gives me good data right now. So we start at the top here. We say set up plotting. I'm going to import date time, import the plotting from Matplotlib, Siphon's catalog class, so we can parse out what's available, the NCSS class for talking to the remote access protocol, and then NetCDF for Python's num2date function. So we grab all those imports. These two lines, we're pointing the catalog at the METAR collection on threads.
Could you go back to, it wasn't clear to me how you found that URL.
Okay, sure. Yeah, I did kind of blow through that.
Like,
So, and this is one of those things that we really need to try and develop a smoother way to do this. But for right now, the unfortunate part is it's go to threads.ucar.edu. Kind of click around here and say, oh, I'm interested in observation data. Yeah, METAR station data is what I'm looking for. Ignore the files thing, really. Just especially right now, the way these files are laid out, you don't want to go through each individual file. And we'll go to the feature collection. And then it's copy and paste this URL.
So you need, if you go back one, so if you're browsing this, you need a feature collection.
Or you could, I guess, you can also start here and copy and paste this URL too. Then you just have to pull out the feature collection in your Python code. So if I go back to the original one, right here, this line. So I say, give me the data sets, pull out the feature collection data set.
So then go back to the website, sorry.
No, that's right. That's this right here.
Go back up. I was just picking around in here one more up. If I went to satellite data.
Yes.
There's no, like.
There is no feature collection for satellite data, sadly.
So that I wouldn't be able to pull it this way, or?
Not using a feature collection. You'd have to go do more, give me the most recent file in the directory. So if we went down to, well, John will show us some of that actually next section.
Okay. All right.
So it's just one way in terms of when we have this collection feature available, for certain data sets, Threads understands things well enough to be able to conglomerate things together and provide you one virtual data set that you can talk to and slice and dice. For some things, it doesn't have that capability, so you've got to manually do it yourself by saying, I want this data file. I want, it's a global data set or it's an image data set, so I'm not trying to subset it. But you've got to manually say, okay, I'll grab the most recent 10 files or do some kind of file name parsing or file name construction or something like that. In my ideal world, again, we would have more of a unified, unifying way to do collections across a lot more data sets, but we're not there today. Okay. So back to going through this exercise. So I point at the catalog, I pull out the feature collection. So I've chained this together in one line just to try and make it compact. But what I've done here is pull out the feature collection and then grab the access URL for NetCDF subset. And I'm handing that to the NCSS class. So it's a lot in one line. It's about 3 steps that we did before collapsed together. But this now I'm ready to start talking to NCSS and make my query. So then down here, let's space this out. Make a new query. Set up my date and time range. So I'm going to go from now to 3 days ago. This was asking for -97 longitude, 35 latitude. So it was around Norman, Oklahoma. And so one thing I do here is you can also chain together the query methods when you're doing it. If you're looking to shorten lines here. So we can say log lat point and then dot time range. Ask for air temperature, dew point temperature variables, and ask for it back in NetCDF. Tell it to download the data. Pull apart the NetCDF file just like we did yesterday. Convert the times. And then plot. And this was the result when I did this. So in theory, only the first half of this is new from what we've done this morning.
For the TDS catalog stuff on the documentation for it, does it tell you what you need then for the kind of URL to look for? So say you want to do a different data type or something like that.
Sure. It's any threads catalog, essentially. So it's a thin wrapper around an XML parser that pulls apart the XML of a catalog. So actually, if you go back to the server, we see we have this web view. I'll go in here. So we have this. What the catalog is really looking at, or what the TDS catalog is looking at, if I change that to XML, really it's looking at this. It's an XML version of what you see with quite a few more tags. To answer Michael's question before, apparently you do have the units available to you without downloading the data, so we could, do that without it. But either way, it's parsing this XML. So it's a wrap around that. So any threads catalog which follows this certain XML schema, the TDS catalog class will parse.
So if you're just like searching for something on the threads website or whatever, you get to a page like this is what you can enter into the TDS catalog.
Yep. I mean, anything that actually looks like anything like this.
Yeah. Okay.
Like this or like that.
Oh, okay.
Either of these. And you can just copy and paste it. And if you forget to change the HTML to XML, you'll get a warning because it's like, hey, I got HTML stuff. I think you meant this. I'll try and change the URL you gave me to XML, and we'll see if that works. But just the farther up the chain you go, the more calls you have to do to try and get it to drill down. And it's that drilling down process that is on the to-do list to simplify. All right. So we used Siphon, downloaded and plotted some more time series data. Let's move out of the realm of plotting time series and start doing some spatial plotting. And so what we're going to work with now is a library called CartoPy. How many of you have used basemap before? Okay, quite a few basemap users. How many of you use CartoPy? Different sectors of the room. Okay, so basemap was originally created by Jeff Whitaker, who also made NetCDF for Python, as well as PyGrib and PyProj, and a lot of other projects we make it take advantage of. CartoPy is kind of a newer mapping library that sits on top of Matplotlib. It's come out of the UK Met Office, and as a result, Jeff's kind of stepped away from basemap, so it's still getting a few maintenance updates because there's at least one of the Matplotlib developers who kind of needs it for production work at his employer, but he has said that as soon as they move away from it, he's done with basemap. So I say that as a way of saying, at your earliest convenience, maybe after this workshop you'll be good with CartoPy, but you should start looking at moving away from basemap. And we'll see here that the CartoPy API is a nicer way of doing projection handling than basemap does, where basemap you kind of had this whole separate thing for plotting on a map. CartoPy integrates with Matplotlib better, and so it's more, after your initial setup of a figure, it's all just Matplotlib calls. And we'll see how that works. So here's how we start off and import CartoPy. Say import cartopy.crs, and then I give it a short name, CCRS. Because I don't like typing cartopy.crs dot whatever. We create a figure. And as opposed to using the subplots command here, I'll use add subplot as a quick way to, one, to make a new axis, but then I also need to tell it, when I create it, I say, here's the projection I'd like you to be plotting it. So in this case, I'm going to be plotting in a Robinson projection. And so this add subplot call, if you hadn't seen it before, saying, I want you to create a grid of axes. In this case, I'm asking for one row, one column, so really not a grid, just a single plot. And give me the first one of those that fits in that grid. So that's it's a quick and dirty way to get an axis that takes up the figure without having to manually specify its rectangle. And then so here, after I've set up this projection, here are a couple methods that CartoPy adds to the axes class related to mapping. We say set the axes to cover the global extent. So you can set the extent and say, here I want to plot this lat-lon range. That's what the map should show. In this case, just show me the globe in that projection. And then it has some default map information here. So here I'm saying add the standard background map using stock image. And so that's what results. Of course, we can go beyond that. CartoPy has a features module within it that has a lot of built-in mapping features that we can add to the plot. So I'll import cartopy.feature as cfeet. Same thing before. We're going to create a figure. This time, instead of a Robinson projection, I'm going to say, let's do a Lambert conformal projection that we want to plot in. After we've created that axis, there's an add feature method that CartoPy's added. And so we say add feature, add the land feature to the map, add the oceans, which are just filled polygons for land area and ocean area. We'll add the coastline feature, so that's outlines of coasts.
So line style, that's the colon.
Yep.
Is going to be just, that's dashed, so it's going to be the
dotted.
Dotted.
Colon is dotted. Might need to crank up the line width to really see it well. So we can add borders. That'll be international borders. And you can, when you're adding some of these line features, you can add just standard Matplotlib style arguments. So we can say add the borders, give it the line style, make it dotted. we'll add the lakes feature and say, make it half translucent with the alpha keyword here. Add the rivers. And then here, instead of setting global extent, we'll say, here's the boundaries I want you to have in lawn space. So basically drawing a box over cones. So the one thing is this library comes from the Brits, so there's no state boundaries built into the library. As I get to teaching this for the 6th time, I really wonder if maybe MetPy should just have that feature baked into it. We added that to the bug tracker yet?
I will.
Thank you. For now.
I know in Python, up the resolution, is that something you can do here? Because like, I love the Mississippi River. It's great that it's like the only one.
Where's the Mohawk and Hudson?
Yes. So the only challenge is you can't do that with the built-in features. Like you can't just say lakes at 110 kilometers or 110 meter rather. What you have to do, and that's what we'll sort of see how we do this with the states here. So there's the natural Earth data set of open, freely available, freely licensed shaped information for the globe. So if we go there, we can see, if we go over to downloads, they have a variety of different types of data sets here. We've got large scale, medium scale, small scale data. So 1 to 10, 1 to 50, 1 to 110. And then you've got these different types. You've got cultural data, which would be your different borders. Maybe roads. I don't throw any in there, but certainly all the different state boundaries, provinces, whatnot. Those are in cultural. Physical will be things like coastlines, oceans, things like that. So you can go in here. Oh, that's lovely. All right. I'm not going to try and dig in any further on that. I don't control them. But at any rate, they have a data set called admin1 states, provinces, lakes, which is borders for provinces and states, including their boundaries along lakes. And so that's what we'll ask for here. So that's under the category cultural. And so Cartipy has built-in support for just going and automatically downloading from that site, hopefully, that data set and turning that into a feature that it can plot.
Once you download it once, we have to do it again.
It's cached locally on your computer. So it's also entirely possible that I will run this and it will work just fine and it will blow up horribly for all of you. So if you hit an error, please let me know. That 404 I got makes me nervous.
That's some warnings.
Yeah, the warnings, I don't know why they made it a warning because it's big, pink, scary letters, but it's just letting you know, hey, I'm downloading something. So that's what I get. I told it, when I made the feature, I said face color none so that it doesn't fill in the states. And then when I add the feature to the map, I asked for a dashed line, and I told it to make the edges blue. And then when I plotted, I asked for the 50 meter scale data, but that's how you could change the resolution of what you're plotting.
How do you know what the name is?
Well, in theory, I was going to go over here, and there's, physical works. Okay. So it's not the cleanest thing, but if you go, I can't. So I was looking at the link where I was going to download it. And that one doesn't show what I was looking for.
At the end, it's good.
Is it any 10 coastline? Okay. So let me see if I can get the states ones and show you that one. If it doesn't work, then. No, the cultural, let's see, different one. Okay. So I went to the medium scale one. And down here we see admin 0, admin 1, states, provinces. and these different options. If I copy that URL, and really I hate that this is the best way to do it, but looking at the URL, any 50-meter admin 1 states, provinces, lakes.
Okay, so you don't need that beginning part then, or what?
No, apparently the any, I'm not sure, oh, not any would be natural earth. So you don't need any, that's kind of their part of the naming thing, and the resolution's in there too. So it's just the part trailing that. But honestly, I have not dug in any further than figuring out how to get my state borders. Beyond that, they've pretty much had what I've been looking for. Okay, so that's how we go about setting up maps and projections in CartaPy, at least, just getting map information. I haven't done any plotting yet, but that's the basics of setting up your map information. So let's go back to NCSS and get some data to plot on this map. So NCSS, the lowercase thing, is still pointing to the same data set it was when we worked with it earlier. We're just going to make a new query. So I'm going to create an empty query. This time, I'm going to say, set up a lawn box query. I give it north, south, east, and west. It's about a 10-degree box centered over, of course, Boulder, because that's where I'm doing all my stuff. But in this case, I'm only going to give it a single time. So I give it start time. Just piggybacking on what I had before, we could do UTC now or whatever. I'm going to ask for air temperature, dew point temperature, altimeter setting again, wind speed, wind direction, and cloud area fraction. And as an example here, this time I'm going to ask for it in CSV format just because I can. Siphon takes care of parsing the CSV and giving you something, the same kind of dictionary access to the data. But if you don't have NetCDF, maybe the libraries aren't available on whatever you're running on, Siphon can still handle parsing text data for you. So you don't have to have NetCDF to make this work, at least for point data. Unfortunately, I don't think we return grids in CSV because that gets sizable.
500.
On what? What happened there? Yep. I'm trying to figure out why.
CSV is not supported for station data.
That's CSS was over.
That's what if you go to the URL, that's what's going on.
Well, I see that. I'm going to see if I can work around it. Nope.
That might be a we're working on the third server issue.
Well, I'll try bouncing it again. But
We were promised that the thread server wouldn't be touched until tonight, but
well, I'm going to go with the data having challenges because we were already seeing weird things. How do I want to go through this?
Mine just ran successfully. So
oh really?
I just 3 times.
The magic number shall be 3, not 2, and not 4.
For some people.
Nope. Okay, well, I'll try bouncing the server in a second, but for now,
Yeah.
Yeah, I did it too, and it didn't work again.
well, for now, here's one I made earlier.
Try running it over and over.
I'm going to crash the thread server.
Yep.
Woohoo. Okay. Well, so that at least I can keep going because mine just refuses to succeed.
I can't get it either.
It's beautiful, if you can see it.
Well, I have the one I did before, so I'll just roll with that for now. So make the query, then here, I'm going to start importing some things from MetPy so we can start pulling apart the data we download and massaging it. So I'm going to import from MetPy calc, I'm going to grab the get wind components function so we can turn the speed and direction into U and V. And then I'm also going to go ahead and import MetPy's unit support so we can use that for some conversions here. Go ahead and get the data again. So that downloads the data. We're doing CSV here, so it's actually just kind of a dictionary of arrays, but it works just like NetCDF, which is kind of the point we're showing here. So we say, pull out the latitudes, pull out the longitudes, pull out the air temperature and dew point. I'm going to fudge sea level pressure by using the altimeter setting. And I'm going to take it, it's in inches of mercury. So we say that by INHG. And I'm going to convert that to millibars. So here we use the get wind components function and pass it the speed and give it the wind direction, specifying that the wind direction is in degrees so that it knows it doesn't need to convert to worry about the radians when doing sine and cosine. And that gives us back the U and V wind components. All right, finishing up here, we're going to take, we have this data cloud area fraction. What that is, that's the NetCDF CF convention's way of saying sky coverage. So we're looking to take the cloud area fraction, and that's in a number from 0 to 1. And so I'm going to multiply that 8 to get that back to the typical METAR octets for sky coverage. And then last, for areas where it's missing, we get a nan. So I'm going to use this little trick here from NumPy. So we have NP is nan. That's a function that loops over the array and returns true for every element in the array that's a nan, a floating point, not a number. And returns false if it's a perfectly fine number. That's another one of those Boolean arrays in NumPy. So we can just pass that to Cloud Cover and use that to set all the missing values to a code of 10. And then last but not least, right now, Cloud Cover is still a fraction or a floating point number, and I want it to be an integer. So this is how we can tell NumPy to convert one array to a different data type. So we take the floating point and say, give it to me as an integer array. And then last but not least, I want the station ID as a nice list or a nice array of strings. So this is one way to take all those binary, those byte strings we saw earlier with the time series and give me back an array of ASCII strings.
I know what that calls that. The start time here. So
start time is whatever it was set to when in that notebook when you're running earlier.
I rewrote the start time to now and then it's -1.
Okay.
The default start time is -1.
Yeah, it's a day ago. Okay. All right, so all that's our way of just taking the data we got and massaging it a little bit to try and get some parameters we want, and we'll see why in just a second of why, why would we want wind components? Why do we want sky coverage and octets? So our goal here is to make a station model plot, like you'd see in a typical meteorology class, and MetPy has support for doing these station plots. So from MetPy, we're going to grab the station plot class. MetPy also has support for doing various of the special symbols we do on these plots. For instance, sky cover has all the sky covered symbols. And so we need some way of converting the codes to the appropriate symbol, and that's what this sky cover function does. And that's why I went to the trouble of converting the fractional values back to a value from 0 to 8. All right, to make the plot here, first we go back to our CartaPy things. We say, give me a figure. Here I'm going to manually create the projection with all the parameters. So I'm going to say, let's do a stereographic projection centered midway over the US. So from -90, longitude -95, central latitude 35. Now we'll create our axes with that projection. We'll go ahead and add the state borders, which we created above the first time. This time we'll plot them in black. Go ahead and add the country borders and the coastlines. So this is another way to do the coastlines on a map. And go ahead and add lat-long grid lines. So that block sets up our map, our plotting.
So the coastlines only are they for lakes as well as for, like for Great Salt Lake would show up?
Great Salt Lake. I'm going to guess no. I think it's only the oceanic coastlines. But the nice thing about using this one is here you could specify the resolution to get 110 or 50 or 10 meter resolution coastlines. Fortunately, that only works for coastlines. So for the rivers problem, you'd have to go back to the natural earth features and do that step. All right. Now to start doing the station plot, we start by initializing the station plot, kind of like we did yesterday with SKUT or Hodograph, kind of creating this plotting object. In this case, we handed the axes we're going to be drawing on. We start by giving it the longitudes and latitudes of all the stations that we'll be plotting. We handed this transform that tells us what is the coordinate system of the x and y values we're being given. In this case, we're giving it longitudes and latitudes. So this is how we tell, when using CartaPy, what we're giving you is in longitudes and latitudes. Otherwise, it will assume that we're giving it x and y values that are native to our plotted projection system. So if we didn't give it this transform, it would assume we're giving it values that are already in stereographic projection. So this plot Curie is a fancy way of saying it's a longitude-latitude system. So that's all we're saying here is, I am giving you longitudes and latitudes. So you need to handle transforming those when you're plotting. And that's one of the nice things about CartaPy versus Basemap is CartaPy will handle transforming between different coordinate systems for you. You just need to tell it what the source data are in. And then the last thing we do when we're setting up the station plot is we give it the font size here, just so it can space things properly. It needs to know up front, how big are you going to be drawing text here? So we set up our initial station plot, and then we say, all right, let's plot one particular parameter. We're going to plot air temperature. I want it to be red. And we'll plot that to the northwest of the center point. Do the same thing with dew point, but plot that to the southwest of the center point. Make it dark green, and we'll also plot the quote-unquote sea level pressure, or the altimeter setting. And we'll plot that to the northeast of the center point. So that's how you just plot a bunch of values, and it'll handle converting those to text and whatnot for you. Here we tell it to add the wind barbs using the U and V components. So that's why we converted those earlier, to get wind barbs at the stations. Here we can also tell it, this is how we tell it to plot weather symbols. So we want to plot a symbol at the center, right at the center point. We're going to give it the cloud cover values we have, and then we pass it that sky cover function we imported above to tell it that's how these values should be converted to your symbols using this mapping. So there's one mapping for sky cover. There's a different mapping for pressure tendency. We have symbols for current weather symbols, cloud types. I don't think anything else is coming to mind right now. And then last but not least, in addition to plotting arrays of values or coded symbols, we can also just plot text, for instance, putting the station ID on the station plot as well. And so we say plot text, instead of using north, south, east, west, you can also just use kind of a pair of offsets instead of the string location. And then, so in this case, if you think of, northwest would be 1, 1, or maybe just, northeast would be 1, 1, or just east would be 1, 0. Using a 2 puts it out further beyond the actual parameters. So this will go 2 spaces to the right if you kind of put a grid around the center point. And it will plot all those station IDs. If you go through all that, this was the result last time I ran this notebook. And so we see you get the center point, you've got the different sky covered symbols, you've got wind barbs, temperature, dew point, and the station ID.
Can you have different font sizes for the different parameters?
I think so. It's worth a shot at least.
Should you like fix that?
That's right. We did try. Yeah, so you
yeah.
should be able to do it. Of course, one of the problems we see here is you get a lot of junk here with things overlaying each other, and you can't even make sense of what's going on in central Colorado. So,
Sorry. One other question about the mean sea level pressure that you applied.
Mhm.
Can you do the traditional?
it's a little more effort, but because of that, there are features in the station plot to handle that. Because
Just getting like 6 stations in a small area with no borders. Is there a way to control them?
Yeah, that's what I go. I had to just keep trying.
I guess you should be getting more stations. I think the server's unhappy today.
The server just got bounced and it's still.
Or maybe the server's not unhappy, but our data source, there's like some bad points in the NetCDF file that are just completely throwing it off. 3 workshops. You guys are the first one where this one has gone off the rails. Well, okay, so we're not setting the extent of the plot, so it's going to adjust the region based on the data points you've got, most likely. So if you're not getting a full coverage within that box, you're probably going to get a vastly reduced region. If you're only getting a few points, okay. So to adjust that overlapping station, or at least in my case where I have overlapping stations, because I have lots of stations, in MetPy we've got a utility to handle reducing the density of points. So for MetPy calc, we can import this reduce point density function. It's going to do this in projected coordinates. So we can go ahead and set up our projection here. And we say, here's our projection. We can use that projection to transform our longitude and latitude station locations. So here we say, our stereographic projection should transform these points from the plot-Curie coordinate system. It's longitude, latitude space. Here are the x values, here are the y values, longitude, latitude. So now we have projected xy points. We hand that to reduce point density and say, make sure there's only 1 point every 200 kilometers. I'm really trying to sparse this out. So again, that's going to return a Boolean array that we can use to mask out the points. So now we have this mask to reduce the points, and we go back to our station plots again. So this is the same thing we did above, but every time we plot something, we pass it the mask, or we take the array and index it with the mask to only pull out those points that were selected. But once we do that, we get much fewer stations here. So Having done that, are there any questions related to this? I know it was a truck through, so the idea would be to, if you're at least having enough luck getting data, we can go through, getting hands-on with this.
Parse has a self-referencing item in the linked list.
Of course it does. All right. Well, yeah. So let's go ahead and try and play with this for a little bit, and also go ahead and take our break here for a while. Say 15. Take a 15-minute break. Feel free to open up the exercises notebook, but I sense the data right now just are horribly in a bad shape. So I don't know that we're gonna get very far in the point data anymore. So.
Yeah, so if you fix the request, what you end up getting is that at this record, 12485.
Yeah, I was already getting that message.
Right, but for some reason,
I don't know what the CSV thing was about, but
that's because there's a semicolon at the end of the address in the Python error message. So that gives you the bad thing. You take the semicolon off, and you get this.
I feared this would happen because it does
This
this.
is really the first thing that's gone sour in this.
Well, the sad part is, it's the first time the point data has done this to me in the last.
It will be available for.
Now it's done it all the time.
Yeah.
Oh, I think we got it solid. We can use this. All the more reason to shoot the Python version.
I already took my experience. Is there anything I should way off?
So let's see. Go.
I wouldn't use that one. Oh.
On this page. So what will happen is under past events, in this picture, click in the scroll down. Past events. So after this workshop is done, we will freeze all of that content. So it's exactly like you saw here. And the link down here will say University of Wisconsin. And that will have the permanent. So that's where you'll want to go.
Yeah. And there's a one problem with my
That's
what is that? Like this is like
You need to launch it.
so when we were working on the like so often from time
No problem.
yeah down to and then I did the reports and a lot of these are Spartan,
But your typical ones that are coming on
that
somewhere before, those ones not coming.
and then you go.
He says if they had special, so it's going to be coming through.
Yeah,
So I don't
instead,
know.
when we were doing the,
there's any number of things.
actually, look at special ones. There was one that came in at 1819, and that was fine. There was one that came in at 1830 something. Yeah, that one was fine.
But then
It's just none of the none of the hourly.
So I don't know if that's just today or if there's an actual.
I'm gonna go with. So these NetCDF files end up being like source of data that So if something goes bad, maybe in English, you're just jumping all over that file and really pulling out the wrong op. We need to not be doing that.
Boils the whole down.
Does it show like itself correctly?
I think Sean is.
It's funny, so I think that also thing
Not
showed up.
No,
but
it's together.
It's a hypothetical set, or-
They were from different.
I think that's a good
Anything would be better at this point, yes, Sean?
They were coming in 120 and 30.
It's a linked list of NetCDF, so if you somehow write the wrong index in there, you're gonna bounce around more, they're all over the file. He just showed me an example of those, Greenville, South Carolina is pulling in a site from Cambodia and Phoenix. Sure, well, if you look at the raw report, you can request that.
Okay.
Yeah, you can see the station ID in there, and it almost seemed like it was in the other side.
Okay, it's funny because, like I said, there were the off-time observations that were coming through.
Who knows? There's no way to know whether or not, I doubt it's a parse issue,
I've been motivated.
I don't think it's a problem parsing the station ID. It's the first 4 characters of the for crying out loud. I doubt it's getting that wrong. Like, I doubt you can do that inconsistently. You don't have to walk very far. But my guess is something went wrong in writing the file and setting up the linked list indices. If for these, that's what those files are. It's a god awful linked list in NetCDF.
Yeah.
So if something goes wrong there, off by 1, you're now into the object key before you.
I will be
An inopportunity or an opportunity crash could be permanent linked list. It's not atomic. You're not writing just another row of files. Whoever designed it was the idea was so that you can have fast time slicing and station slicing. It's not that slow to want to incur that much complexity. Versus, let's just write the new ob to the end of the file and be done with it. That would work just fine.
All right, so question. Until I figure out kind of like how, even if it's possible to
If we get these first two,
questions,
at least look at
because when I look through like,
and a model.
what you guys have,
The maps
it actually,
tools we use for that, to me, is still long-term.
so you can see that it's kind of pointing back to this guy. It kind of makes me think that.
I think long term.
The question is, with Gem,
Okay, well,
I mean, just all you need is stuff between the hashes as a way of saying, hey, look here for a time
Complex.
to know what time to. So
Do, then we're gonna have to.
I don't think
Tools that are own.
something
Right.
that's doing anything specific to NetCDF, because really how NetCDF Java works is the IO layer is handling, turns the Genpack files into something that works like NetCDF. And the point feature collection is you can just sit on that and works fine, assuming that the Genpack supporting NetCDF Java can say, oh, I understand this is point data. Let me make it look like NetCDF point data.
Here are all the modes.
That's the metric step. It does that, that will work.
okay. Let's say though that, so I'm gonna assume that will work eventually, but let's say I just wanted to pass in the NCSS URL that I'm getting from my source. So.
Yeah, I
how-
mean, maybe there's a mix, right? You can make some regular blocks.
Here's what it looks like now.
The easiest way is, can you go back on that?
Right, and I think, I mean, but yeah, I think ultimately having a common.
So I would hand the catalog parser that URL.
But, I mean, maybe certain features that, I mean, it depends on the diagnosis.
This or this.
I don't know.
Oh,
But, you know, for these sort of basic type things, as long as they look nice, I mean, if it, you know,
Even though
maybe the ways to make it look nice, ones that seem.
They're okay, but they're better ones, yeah. I think they're better ones. And you know, I mean, the plots that I was putting together versus the ones that are 2000s, I think like this. Pretty good.
So
I mean,
I would put that down in here for the NCSS URL.
so actually you put it, no, take that and put it in, replace the V to our cat URL.
We can do that too with Genpack. We can make it. I mean, I'm not saying let it to that, but I think in terms of getting something, we know what's going. It doesn't have to be stupid. It can also.
And just.
What would you like to see just for example?
Yeah.
But I think the models.
Yeah.
Oh, make it.
Well,
It also.
that sounds good.
And there's a. Press or whatever that says.
I'm trying to get this
That's fine.
That's
So replace feature collection with that.
And another thing that we could think of is feature collection.
So again, there's a lot of API calls to make Siphon here.
There's a lot of.
Oh, here.
Yeah.
You want to host this?
Okay, so I would actually just put it in 17.
Yep.
Being a hub where people can go to find specific.
If it's already understanding that file of NCSS,
Siphon stuff.
the feature collection absolutely will work.
And then either they have that stuff.
That means NCSS is understanding that it's point data. Golden.
We think if there's someone
Well, that's because of the data variable stuff.
Alright, it's got
Just
Jim
got
back.
JSON.
It's got Jim.
I mean, it was not.
You can also see. We've got a warning there, I think. Type, attribute, type, like.
Yeah.
What's the error action thing?
Yes.
Keep going up, click up to your query, and the queries where the problem is. There it is. Oh,
Next question?
yeah.
So for you did the transform, the plate carry thing. I kind of figured this all out, kind of, like if you're trying to speak Italian by just using the dictionary, I have no idea what you're saying.
Yes.
Try to get through word for word. I did manage to come up with a plot that looked Japanese. I had to do some transformation. My grid was on like LCC, and then and I had to do this thing. You pick your corner, latitude, longitude, and then you have to derive what all the latitudes, longitudes, and all your points. It was incredibly complex. So there's probably an easier way to do it, but so when you do the transformation, you say, I have a grid, I have an LCC projection, that's my axis, right? And then my data is latitude, longitude. So when you do the transform, what you're passing it, you have to transform from this to what's on your X.
Hey, we're getting somewhere.
Just calling the plot method,
Yeah.
you're telling it what transform.
Because here with your station data, it says it's basically
Lat long.
Yeah, like Curry or whatever,
Yeah.
right? Effectively, right?
So that's, and so if you've got a lat long grid, same thing, use plot grid. So
Right.
transform equals plot grid.
Right.
And that's saying, here's what my data are in.
Okay.
And then it handles going between the two.
Okay, so, but I mean, if you wanted to say, take a grid you want to make a grid that's an LCC projection, and your data's in a different projection, when you use the transform function or whatever in there, you're saying transform from this to
Yes.
what's on my X.
I mean, I tried UTF-8 after the.
And it can do, it has some sophisticated capabilities in regard to trying to reproject image data and things like that. It can be a little slow, but you can get some really nice little plots that way.
I'm curious about, are you familiar with paintball plots? They're used in ensembles to show.
I mean, the range is right.
On each
I mean, it's kind of
person.
interesting
Typically
that
what they do is you
I
get a
think
threshold
It knows,
It kind of knows
value
the
for
range.
range or DBZ, whatever you're looking at. And
So just look at what the array looks like.
each member gets its own color, and then they're layered on top of each other with sort of quasi-transparent fill
Okay.
patterns. And I was just curious, the transparency part's the part that gets me. I'm not sure, do you know offhand?
Alpha is your keyword in that plot with regular transparency.
Okay.
Off initial cut in my head, I don't see any reason why you couldn't do that.
Okay. Cool, because I know I saw a guy at a conference that wrote full plots, and he said he didn't understand Python, but I didn't know.
Yeah. Alpha is how you control the transparency.
Okay, thanks.
And that should apply to any kind of plot you want. You can tweak the alpha. Probably a contour fill is where you.
Yeah, yeah.
And it definitely has alpha.
Right.
Close to the cigar.
Yeah, we're getting there. I mean, no errors, but it looks like there's these gaps.
Yeah.
Yep.
with a mask that says false on when it's actually data and true when it's dashes.
That's because, well, the masked for masked array is inverted from our mask that we use to pull out data. So masked there means, is this data missing?
If it's true, it's missing.
Yeah.
Okay. And I mean, the interesting thing, I mean, look at the range here. So we've got 14.4 to 11. And you can see that somehow it knows that the axis
it's correctly assigning the y-axis.
Are you
I'm just
setting a
not doing.
time range there? Yeah, that data should be plot just fine.
He's still getting that white roof.
Yeah, well, that's not gonna go away, but I need to go.
Should I just try
It's a
like
site
the
issue.
hours? Maybe go back and use. That's fine. I'm sure it's. I'm just kidding. Well, it's fine. Yeah. See, maybe trying to go back a full day and there's not because of the demarcation of the. Now let's just go back 12 hours. Let's see what happens.
I thought you had no problem with the missing data. But it's not there.
It's definitely getting the time.
The time locator stuff,
The time record stuff.
plot, the time, that stuff, yeah.
The stuff.
I'm looking at see what you're throwing it off. That's so weird. Can you see your plotting again? Where's the plot? Okay. So plot temp data. Is temp data actually the current array? So we'll put in there.
Well, I mean, I printed it out here.
Yeah, okay. No, that looks.
Certainly seems to be parsing the. It's definitely picking the right y-axis. It's just not finding the
Do
points.
temp data dot
Yeah.
see what happens. When you're plotting. So temp data, what's it? Plot temp data dot data. So that's kind of in the master array pulling out the raw.
All right, so it's trying to plot
Actually,
minus 999
you know,
instead.
what I think it might be doing is it's trying to make a line plot, right? Exactly. With mass data, it will skip the segments. Instead of like filling in, it'll just draw segments only connecting the actual data points you have. You don't have connected data points.
You have one with a gap, one with a gap.
Exactly. So actually, if you get rid of the dot data, so like the plotting temp data is temp data dot data.
Temp data dot data.
So get rid of the dot data. And color after color. After that inlet string, we got another parameter that come up. Marker equals quotes, quote O. No.
Oh.
So you use circles. All right, there you are. Okay. There's always an explanation. It's just sometimes confusing until you get there.
All right, great.
So the missing data point. But
So
yeah,
that's nice. So that means I can definitely point to the.
and once you get a feature collection,
Yeah, and then probably don't have to worry about all this NetCDF Pearl stuff.
that would be the way I would go definitely, because that thing is.
I'm guessing that's the working, so I'm gonna, for the heck of it, try.
Sure. Just know that you too could have a day that goes horribly wrong because something gets missing code.
That's not good. This doesn't have to be this stuff.
It's just good old fashioned jam pack. Tried and true since 1934. Whenever they're hurting it.
You can even generate NetCDF files.
Get out of the dust bowl, Rose. You're watching this live.
I guess, I mean, we're moving on to satellite at this point, right?
I was gonna say, I think that's totally done.
I'm not in the headspace to deal with any more point data right now. I want to burn that thing to the ground.
Well, now we have to.
Had good motivation before, just other things became more motivating.
In the words of Sean Connery, we were talking about the other day.
It could have been.
Has British ships reached the end as a result? Then we're very motivated.
I got another quote from The Rock, but I'm in range of a hot mic. Oh yeah, let's.
State orders is not. Oh, yes, sorry.
Summarizing.
So as we're going to switch over and let John start talking about some satellite data, which I know is near and dear to the hearts of many in this room. Any closing questions about the point data other than the fact that it, blew up spectacularly? All right.
One comment.
Yes.
Back the time off a couple days.
Sure. That goes with the theory that somewhere a new ob came in and that script went horribly wrong and made some bad NetCDF files. But unreliable data is almost worse than no data. So we need to improve that processing or replace it with something that works. You can start over. All right, do you have the feed now? Do you have the?
Yes, I do, please.
All right, good deal. Okay, so we'll probably end up splitting satellite data over lunch. We'll see how time goes, but I don't want to rush through it. I mean, unless you want to. I know nobody here is into satellite data, and it's not near and dear to anyone's heart. But if you go to the notebooks main directory, go down to satellite data, you'll see that again, we've got a couple notebooks in there. We're going to start with this. Oops, except I clicked surface data. Satellite data. We've got working with satellite data. That's the one we're going to start with. And you should see a notebook that looks like this. Everybody good there? All right, so again, I'm going to go to cell, all output, and clear here in these top menus, just so that everything is cleaned out. You don't see the old images from last time we ran this notebook and put it in the repository. Give us a fresh slate to work with. And normally, you'll grab your satellite data from threads.ucar.edu, like we did with data this morning. All the operational satellite data is there. We wanted to play with some of the Go16 data, which is not operational, therefore it can't live on that server. So we have it at threads-test.unidata.ucar.edu. This is a testing server. If you click on that link, you will be taken to another thread server that looks very similar to the one we were just on. We notice there's this test datasets directory. So if you click in that, we have a Go16 products directory. There's a Go16 folder. So you have to just keep drilling down. And finally, we get to a folder for each day. So you can see we've got data, it looks like going back roughly a month here, archived. And all the way at the bottom is 0606, so today's data. And there it is further broken up because there's so much data coming down from this in different ways. We've got CONUS, full disk, and 2 mesoscale sectors. So I'm just going to pick CONUS to show you that now we find the 16 channels of data. And pick a random channel. And finally, we get to all these NetCDF files that contain the image. So the images are coming down to us as a bunch of tiles. On the thread server, these tiles get assembled and dumped out as one big NetCDF file. So it's easy for you to grab and plot. But as you see, we're if we look at the path here, we're way down in a bunch of directories to get to this. So what we want to do in our Python notebook is make it versatile, where we could change what channel we want to get, or we could change the date, change what region, whether we want CONUS or full disk. When you're doing this activity, I don't recommend full disk. It will take a long time to download and a long time to plot on most machines. So I would stick with CONUS or Mesoscale 1 or 2.
Before you do that,
What's the source of this? Is this like the GO16 data that's over the null port feed that's formatted for AVIX?
Yeah, so this is stuff that's coming down over Nova port that we're stitching together and putting up as NetCDF for. Yeah.
and if you just describe your file names, what are they telling you? 2-kilometer resolution, is that the center point that's given?
Yeah, so that is the center point and then the wavelength. And then 2-kilometer resolution.
The full disk actually are not too bad because they resample them down to 6-kilometer or roughly 6-kilometer resolution. The CONUS channel 2 visible are probably the biggest, so those are about 100 megabytes an image. But the full disk ones aren't too bad. From here, the raw stuff coming down from the satellite's huge. It's huge, yeah. But these are the processed ones.
We have had some luck plotting them, but it did take a little bit of time at probably reprojection.
We can talk about it Thursday.
Yeah. All right. So did anybody have any problems getting to where this lives? Or yeah?
Well, I'm not there.
Okay.
Do we need to do it or just?
No, we're going to see it in the notebook. I just wanted to show you how to get here so you know and can navigate. Okay. So if we go back to the notebook, you can see I'm going to do something. I'm going to use Siphon to get this off the Threads data server. And then I built in some flexibility here. So we'll run through this cell line by line. Of course, we're going to get date time, and from siphon.catalog, import TDS catalog object. For this exercise, I assume that we want to get the most recent image. The most recent is we can safely get. So I use datetime.utc now to give me the current time, and I'm going to format that. So this is, I want to make a string out of that with the year, the month, and the day. If we look back on our thread server, see right here we have year, month, day. So I want to make a string that looks like that from the current date. Channel, I'm going to pick channel 8. If you need a channel reference, I don't know if many people here will, but if you Google GO16 channel, you can get these quick information guides. I'll tell you what the different channels are and their wavelength. So channel 8 is a mid-level water vapor. And then for region, I'm going to use Mesoscale 2. If you want to change yours to Mesoscale 1 or CONUS, capital, you can do that. And then I build my URL. So I copied that URL from the web browser, that whole long catalog URL. So threads test, Unidata, threads, catalog, satellite, GO16. But then I have these curly braces where I'm going to insert the date string that I made up here, so the year, month, day, the region that we typed in, and channel 8. It's just a nice way to build that URL. Okay. And we get all of the data sets for that channel and that day back. So here I'm just showing the last 5. Remember, we're going 5 back from the end of all the data sets that are available. So you see we've got currently 1628. So we've got one here from a couple minutes ago and going back in time. We're going to get a data set. Ideally, we would use -1 here to get the most recent data set, the last item in that list. But on occasion, if all the data don't come in quite on time, you don't have all the tiles to build the image,
you don't get a full image. So I'm going to use -2. Just go back and get the next to most recent data set out of that list. And then we'll pull it out of all those data sets in the catalog. Just roll up to the people back.
Just sorry. So in the first sort of block, you had specified the date as being UTC now.
Right.
Instead of year, month. Okay, so I guess year, month, and day. But why are we getting multiple and multiple, like 5 of these files being identified at different times when that's?
So I've limited it to year, month, day.
Okay.
So on the server, it's going into the folder for today and getting everything that's in there.
Okay,
So
going
all
back
data.
5.
But
5 most recent in that list is what's being listed up.
right.
Okay.
So if we look at everything, there's all the data
Got it. Okay.
from today. And Ryan, have you showed this GRF time in
No,
detail?
that's new.
All right, let's take a second and look at that. So if I just run datetime.utc now, I get the current time, TC. So 16:30, 28 seconds, and some fractional seconds here. We know that on the server, the folder just takes year, month, day. So we can use another datetime function that makes a string out of that time. So we're going to parse the time and make a string of some specified format that we specify in here. If you Google Python datetime to get the documentation page, we get lots of information, but the most useful thing, and what a lot of people keep in one tab that do this, is this table. It tells you all of the different formatting codes that you can use to either parse a string into a datetime object or take a datetime object and make a string from it. So for example, a lowercase a is the weekday is the abbreviated name. So if I go back here and use the lowercase a, you see that it's Tuesday. So we can, capitals the full name. So we can limit that to whatever information we want. So J would be the Julian day, so it's Julian day 157. So what we're doing up here is making year, month, day all smashed together, which is going to be part of that URL. Let me grab the server too. Being able to take date times and make them strings and take strings and read them in and make them date times is really useful to be able to do. But there is a little bit of magic in getting all the right incantations. Okay, so did everybody get a data set object returned when they ran this cell? All right. So if we print data set, see that we have a handle on this object. And as Ryan mentioned, you can access these in quite a few different ways. So you have HTTP, there's NetCDF subset service that you used earlier, WCS. We're going to use OpenDAP for this data. So in this dictionary, the key OpenDAP has the value of this URL. So from the NetCDF 4 library, import the dataset object, and I'm going to point the dataset at the OpenDAP URL that's in that dictionary. So now if I print out DS, you see that we have a NetCDF object, sectorized cloud moisture imagery, CMI. So if you'll open up the Working with Satellite Data Exercises notebook that's in that same directory, You'll see, much like yesterday, giving you a skeleton to go retrieve some of your own data. So do this down to the horizontal line here. So exercise 1, where you go and get your favorite channel of data from any time that we have on the server, which is in the last month. And put your green stickies up when you're done.
something weird with your full disk stuff, because there's 2 files for each of them. Like they're not getting pasted together. Right?
No, one's the full disk and one's Puerto Rico.
Oh, okay, I got it.
But Tom's already suggested I do something about that. And I want to, but
Are they coming through in a different, in the same header somehow? Or?
well, they're both full disk source things.
Right, because Puerto Rico is not.
And so the encoding for that, like I'm keying off in the directory, I'm using the source scene. Well, that's for both of those is full disk.
Why I'm not getting that because my full disk.
Maybe you're only grabbing. I'm not doing much with the WMO header. I'm doing everything in the NetCDF file.
Yeah, I'm doing it with the WMO header, and I'm actually just saving the individual tiles and using my plotting program to piece them together.
But the problem is the Puerto Rico part's encoded in a god awful part of the NetCDF attributes. It's not something same that just says Puerto Rico's view or whatever sector.
Yeah.
Nope. So I've got to go in there and probably. There's a place where I can find something or I can look at something, but it's more. It's not general. It's going to have to be a one-off hack in there. Say, if it's this, you should rename this Puerto Rico, or we'll have the same thing with S and Alaska and Hawaii.
Right.
But
okay.
I
just have like there's 2 files in here. Not
yeah, I think if you look carefully at the file name, there's a difference in the center point because that's one of the things in the file name is the center point.
Yeah. The lat longs are not the same.
Yep.
Which is why I was thinking that they weren't getting pasted.
Gotcha.
Like you're only getting, because there's 4, I think with the CONUS, there's 4 chunks where there's like a 1024 by 1024 and then a skinny one and then a short
Actually,
one.
I think those are the mesoscales. The CONUS is like 100 chunks.
CONUS, no.
CONUS Viz.
No, well, yeah, the CONUS is big. The global, I'm sorry, the full disk.
Full disk, yeah.
Full disk is like 4.
Yeah.
There's 4 chunks. But they're not equally sized. They're some weird size. So like the first one's 1024 by 1024, but the whole image is like 1600 by 1600, so it ends up being squashed.
Gotcha. An issue on Cardify. We'll see if there's any interest on having states provinces feature. And hey, we just that's something to help us deal with rivers and high resolution. Right. Instead of streaming it with MetPy, go upstream if we can. Makes sense. Trying to find one. Next section, I think, is pretty short. Oh, yeah. With this section, go slow and let them play.
Yeah, the next one's 4 cells.
This is getting the. Okay. I mean, I don't mind. But just giving them the time because this is the. For many in here, this is the most interest.
I don't think because if I can do this, it's going to be time. I'll do the exercise on this. And not have seen it for the last hour. It's not hard.
Hmm.
So if you have data, make sure you put your green sticky up. If you don't have your data yet, that's fine. Just trying to gauge how much we should do before lunch.
Yes. So that is. That's the next.
That's the red.
Is right here.
Right here. Okay.
You get the name and then here your action.
It's like
Z data set.
2,000. Okay. Not even the other one, so it's like 10 or 12.
There's a good
sections of
data
skills.
That's what we do.
And then converting them all because
This data set
is
is
I
that
use
data
one of the
set.
ones that I
That's where you're getting to that data set. From the
This
data
one's
set.
a 0-1.
Sure.
Okay, so that's really what you want here.
Yeah, I forgot.
Well, and I need to.
Okay, so most recent, okay, so these two.
I just want to make sure, but I can't stop working on this.
So that's. Oh, it's printed from that. I didn't say print data set thing. I did that, I would see.
Yeah, you'll see the full. That's one part. Threads.
And this seems cryptic.
Oh, it's, no, this is just.
It's always on the.
Oh, okay.
So that's just telling you that data set is
Freebie from
Siphon
Swag
data set.
from Supercomputer.
Because it doesn't, Python doesn't give a data set.
I mean, what are we talking?
It
50
doesn't,
quadrant?
yeah, just say, this is what it is.
Is there a better thing to use here? Just
You don't have, I just used it until like half an hour before we got back. And then the address.
Yeah, no, better than nothing.
That's right.
Okay. And only when I see the text, I think, oh, this is there.
And then.
Like,
Yeah, it's it.
Largely very
More
much.
citizens.
I like it. It is just around that time. Well, you know, we can shift things around, so.
I'll show this. I'll do that after lunch.
Yep, that sounds like a whole plan. I like it.
Okay, so it looks like most people have their data set. So I'm going to show you parsing out the NetCDF file, which is something that we've already done. So it shouldn't look too unfamiliar. And then we're going to go get a group picture of everybody before people end up scattering. And then it will be lunchtime. When we come back, we'll do the activity on this. And I will give you, no, I won't because it's not rendered yet. We will be making an image first thing after you do this activity after lunch. So we're almost there. Okay, so you should have your NetCDF object. In this case, we called it DS. So just like before, we can list the variables that are in this NetCDF file. We have the y and x coordinates, Lambert projection, the projection variable that contains all the information about this data's projection, and then sectorized CMI, which is actually the image. So what I'm going to do is get a reference to that sectorized CMI variable object. I'll call it data var. And so remember, this isn't the data. If I wanted to actually get the data as an array, we'd have to have an empty slice there. like we did with the SQT and surface this morning, but I actually want the variable object. Because there's a lot of metadata attached to this variable object. So it tells us the units, which we used this morning. A really important one is this grid mapping. So that tells us what projection it's in, or it tells us the name of the projection variable, which is Lambert projection. So notice that's one of the variables up here. If we had a different data set from a satellite or processed a different way, that would have a different projection name that references a different variable in the NetCDF file.
You may describe this, but I'm curious, is it possible to remap it to a different projection?
We will do that. You can do that with Cartify when we plot it. Yes, it is slow.
Like, instead of that, you use like metadata from the actual data, the CMI data, like, because that also has grid mapping, and then you don't have to know that it would be called Lambert projection in case they would sneaky change it on design.
So that's where this is just a string that tells you what the name of the projection variable is. So if they changed it, this would change and that would change.
Okay.
And we'll programmatically
Okay.
do that. Yeah. That's, you could hard code, you could say, I know that the projection is in the variable Lambert projection, but yeah, if they sneakily changed it on you, then your code would break. So we'll go around that. Yeah. You can also see some things like the shape. Okay, so we know we're going to need X and Y. So we can go ahead and pull those out from the variables. Get X, get Y. We use an empty slice. I'm going to, if we print X, see we've got now a big array of numbers. So we have an empty slice there. And here's what we were talking about. So we're going to get a variable from the NetCDF file, and the name of that variable is datavar.gridmapping. So let's break that down. Let's put a cell above and make sure we all understand what's going on there. So the grid mapping metadata attribute on the data variable object is Lambert projection. So we're going to plug that into here and pull that variable out of the NetCDF file. That way, if they change the projection information, this will still run perfectly fine. That makes sense or clear as mud? Yeah, okay. So we're going to pull that variable out, call it projvar, because it's going to have all the information we need to make our map. If we look in it, see LCC, the parallel, longitude of the central meridian, latitude of the origin, and then the semi-major and minor axes of the globe that were used on this are equal in this case, so sphere, but they still decide to specify a major and minor axes.
Why is Lambert projection in the actual variable output then if we're going to grab the view of the data mapping?
Not sure I'm following.
So if you grab, if you scroll up a little bit, out the actual variables, you have like the four things that are
Right.
Lambert projection here. But you're accessing it via sectorized CMI, correct?
Correct.
So why is it listed in the variables here if we're going to grab it via sectorized CMI?
So
Because if you print out Lambert projection off of this variable right here, it's the same thing. Right?
we're accessing the same thing.
Okay.
So this in sectorized CMI, which is, we called it data var here. So that's sectorized CMI. The grid mapping attribute is just the string Lambert projection. It's not actually the variable.
Okay.
And so I'm using that right here.
Oh, okay.
So it's the same as if I typed Lambert projection.
Sure.
But I'm just plugging this bit of code in there. So if they do change the projection or something like that, this will all just keep working.
Right.
We don't have to hard code it in. So we're accessing the same variable.
Why isn't it just generalized like projection? So you can grab that variable and then you have the data from that?
That's a really good question. All I can say is that what they're doing here follows the climate and forecasting NetCDF conventions, and that's how they decided to do it. And yep.
It's a very long way around to get to it.
And also, I mean, some of these date back to NetCDF 3, where there were no things as groups that you could use, where some of this might make more sense as a group. So
if you had a bunch of things shoved in one file, I could see some variables having different projections and having multiple projection variables. So you could have a Lambert projection, Mercator, whatever. Yeah. So that's a confusing step. So I'm glad we kind of walked through that because it is not straightforward why we have to do that. Any other questions on getting the X or the Y actual data values and getting a handle on this projection variable object? No? Okay, so after lunch, you're going to do this on your data, and then we're going to start plotting it up. First, we'll make a really naive plot where we just throw the array up on the screen with no projection, and we'll project it, do some color mapping, and at the end, I will show you how, and if you're on a non-Windows system, you will probably be able to make an animation as well. All right? So,
Sorry, what does CMI stand for?
All right, so we're going to get a group picture of everybody. Where are we going to?
We'll do it on the roof if you want.
Yep, sounds good.